Welcome, I am Mrs. Tonioli, and today we are going to be learning about evaluating expressions in real-world problems. So we're going to take what we learned last time and apply it to some real-world situations. So our target today is to be able to use the order of operations to evaluate expressions when we are given a specific value for the variable. So let's review a little bit of our vocabulary that we talked about. Remember, variables are letters that stand for numbers. They are values that can change. That's what variable means. It can change. An expression has no equal sign. It's a number sentence that has no equal sign. An equation is two expressions that are equal to each other. So an equation has an equal sign between the expressions. Today we're going to be looking at some equations, so they're going to have equal signs, but we're really only going to be dealing with one side of the equation, or that expression right there. So let's jump right into this and see what we have here. So Julie wants to fence in her herb garden. If she wants it to be 8 feet wide by 10 feet long, how much fencing will she need? Let's put that down a little so we can see it all. How much fencing will she need to install? So we're going to use the formula that the perimeter of the fence is 2 times the length plus 2 times the width. So just like last time, all we're going to do is substitute some values in. So we know what L is and we know what W is. So we're going to do 2 times the length, and the length was 10, plus 2 times the width, and the width was 8. And then we're going to use our order of operations to solve that expression. So I have 22 times 10 is 20, plus 2 times 8 is 16, and 20 plus 16 equals 36. So my perimeter is going to be 36 feet. So the correct answer would be B, 36 feet. All right, let's try another one. Ricardo wants to install a dog run in his backyard. If he wants it to be 15 feet wide by 18 feet long, how much fencing will he need to install? We're going to use that same formula that we're looking at perimeter, and the perimeter is 2 times the length plus 2 times the width. And I know what the length and width are, so I just need to substitute them in. 2 times the length, which it says is 18, plus I like that equal sign, plus 2 times the width, and the width is 15. Now I'm just going to use my order of operations. 2 times 18 is 36, and 2 times 15 is 30, and then I'm going to add those together, and I get 66 feet. So it looks like Ricardo would need 66 feet. There we go. Ricardo would need 66 feet for his fencing. All right, we're going to use a little bit different formula on this one. Now we're going to be looking at volume, which is how much will fit inside of something. So Marco is packing a cube-shaped box with a width of 6 inches. He's packing it with sugar. Using the formula volume equals the side cubed, determine how many cubic inches of sugar the box can hold. So volume is length times width times height, and since it's a cube, the length, width, and height, they're all exactly the same. So that's why we can do S cubed. So we just need to substitute the value of S, which is 6. So we have 6 to the 3rd power, and we need to figure out what that is. So that would be 6 times 6 times 6. So that would be 36 times 6. And 36 times 6 is 216. So our correct answer would be C. He needs 216 cubic inches of sugar to fill that box. Okay, put the video on pause and go ahead and try this one yourself, and then check your answer afterwards. So once again, we're looking at volume. Henry's packing a cube-shaped pail with a width of 9 inches with sand. So we're going to use that formula, volume equals the side cube, to determine how many cubic inches of sand the box can hold. So all I need to do to find the volume is substitute the value of S, and it tells me that S is worth 9. So I have 9 cubed. So 9 cubed means 9 times 9 times 9. So 9 times 9 is 81, times another 9 would be 729. So my answer is 729 cubic inches of sand. That is what the box can hold. All right, we're going to try a surface area formula here. Amber needs to wrap a cubic gift box with side lengths of 3 inches, but she isn't sure how much wrapping paper she needs. So we're going to use the formula. The area of the box, the outside of that box, is 6, because there are 6 faces, times the side squared. The side squared would be the area of one of the faces. So we're going to calculate how much wrapping paper she would need. So we just need to substitute the value of S, which it tells me is 3. So I have 6 times 3 squared. Now you do need to be careful on this one that you make sure you only square the 3. I don't want to do 6 times S first. I do exponents first, and the exponent is only on the 3. If I wanted to multiply it first, I would have to put parentheses around the 6S and then times them and then square it. So make sure that you're only squaring that 3. So 3 to the second power is 9. So I would have 6 times 9, which equals 54. And I have mine all as a exponent there, which we don't want. Okay, so it looks like Amber will need 54 square inches of wrapping paper to cover her box. Okay, put the video on pause and try this problem yourself, and then hit play and check your answer. So again, we're looking at how much wrapping paper can cover a box that Jasmine is wrapping. It tells us it's a cubic box, so we have 6 squares on it that are each the same area, which we would get by doing length times width, and since it's a square, their length and width are the same, so we can do side squared. So we just need to substitute 11 in for S. So we would have 6 times 11 squared. Remember, we only want to square the 11. We don't want to multiply it first. So 11 squared is 121. So we have 6 times 121. Whoops, I really like my exponent there. 6 times 121, which gives us 726 square inches. So Jasmine is going to need 726 square inches of wrapping paper to cover her gift. All right, again, Mrs. McQueen wants to know how many feet her dog runs when she is racing around the backyard. If the backyard has a width of 55 feet and a length of 75 feet, how many feet does her dog run? We're going to use that formula, that perimeter equals 2 times the length plus 2 times the width. So pause the video and do the problem on your own, and then see if your answer agrees with mine. So I'm just going to substitute the value of L and the value of W. So I'm going to substitute that length and width. So I have 2 times the length, which is 75, and I have 2 times the width, which is 55. And then I'm going to follow my order of operations. So 2 times 75 is 150, and 2 times 55 is 110. I'm going to add those two things together, and I get 260 feet. So her dog will have run 260 feet. Mrs. Skates needs to wrap a box with a side length of a ½ foot, but isn't sure how much wrapping paper she needs. Use the formula. The area would equal 6 times the side squared to calculate how much wrapping paper she needs. This is no different than when we did it before, except that we do need to use our fraction operations correctly. So pause the video, see what you can do on your own, and then check it with my answer. So I'm going to replace 1/2. So I have 6 times 1/2 squared. And I'm going to see what I can do with that. So I need to do 1/2 squared first. So that's 1/2 times 1/2, which is 1/4. So I would have 6 times 1/4. If I multiply the numerator, 6 times 1 is 6, and 4 times 1 is 4, so I would get 6/4, which in simplest form would be 1 2/4, or 1 1/2. So she needs 1 1/2 square feet of wrapping paper. All right, this is just a little fill in the blank. So if the formula for area of a rectangle, where A represents the area, L represents length, and W represents width, the formula is the area equals length times width. Okay, so to find the area of a rectangle with a length of 10 and a width of 5, we would need to replace the L with the length, which is 10. And we would need to replace the W with the width, which is 5. And our next step would be to then multiply 10 times 5, which is equal to 50. So the area of the rectangle would be 50 square units. All right, this problem is not a real world problem. It's just a little bit of review from what we did the other day, where we are going to just substitute our values in. So we're going to substitute 84 and 1500ths in for N, and we're going to substitute 1 8/10 in for F. So if we do that, we have, let's see, I can't see my thing. We have 84 and 1500ths minus, let's just move this down a little bit. There we go. So we have 84 and 1500ths minus F, which is 1 8/10, times 8. Now I need to follow my order of operations, so it would mean I would need to multiply first. So I'm going to do 1 8/10 times 8 first, and I get 14 and 4/10. So I have 84 and 1500ths minus 14 and 4/10. And then I can go ahead and do that, 84 and 1400ths minus 4 and 4/10. Let's see. And I get 69 and 7400ths. So my expression would equal 69 and 7400ths. All right, another fill in the blank here. This is the formula for the perimeter of a rectangle, where the perimeter P represents the perimeter, L represents the length, and W represents the width. So to find the perimeter of a rectangle with a length of 8 and a width of 4, we would need to replace L with the length, which is 8. I'm going to do this in color this time, I think, which is 8. And we would replace W with the width, which is 4. And then we would do 2 times the 8 plus 2 times the 4. And that would be 16 plus 8, which is equal to 24 units. All right, this is the formula for the area of a triangle, where A represents the area, B represents the base, and H represents the height. So our formula is area equals 1/2 the base times the height. So if we have a triangle with a base of 6 and a height of 8, we would replace B with 6 because it says my base is 6, and we would replace H with 8 because my height is 8. Then our next step would be to do 1/2 6 times 8. Now this is all multiplication. That means 1/2 times 6 times 8, and the commutative property says I can multiply in any order. So I could do 1/2 of 6 first and then times it by 8, or I could do 6 times 8 first and then take half of it. However you want to do it, you're going to get the same answer. So 6 times 8 is 48, times 1/2 is 24. So the area of my triangle would be 24 square units. All right, this is the formula for volume of a rectangular prism, where V equals volume, L represents length, W represents width, and H represents height. So to find the volume, we would do length times width times height. So to find the volume of a regular rectangular prism with a length of 4, we would replace the L with 4, a width of 5, so we would replace W with 5, and a height of 2, so we would replace the height with 2. The next step would be to do 4 times 5 times 2. Again, you can multiply them in any order because the commutative property says that we can do that. So 5 times 2 is 10, and 10 times 4 is 40. So the volume would be 40 cubic units. All right, let's just practice evaluating some expressions with some decimals and fractions, so practicing those operations. Go ahead and pause the video and substitute these values in for this expression and see what you get, and check your answer with mine. All right, so I substituted the value of 4 in for x and 2 and 4/10 in for y, and then I'm going to follow the order of operations. So 3 times 4 is 12, and 2 times 2 and 4/10 is 4 and 8/10. And then I'm going to add those together, and I get 16 and 8/10. I hope that is what you got as well. Okay, let's practice with this one. We have 5 times the quantity of n plus 3, subtract 7n, where n equals 1/2. So we're going to practice with our fractions there. So I'm going to substitute 1/2 in for n. So I have 5 times the quantity of 1/2 plus 3 minus 7 times 1/2. All right, so 3 plus 1/2 is 3.5. So now I have 5 times 3.5, which I could change to a decimal, but I'm going to go ahead and leave it as a fraction, minus 7 times 1/2, which is going to be 7 halves. So now I'm going to do 5 times 3.5 first. I think the easiest way to do that, and I'm going to draw it out here so that I can do it a little bit better, is to change that 3.5 into an improper fraction. So I'm going to change it to 7 halves, 5 times 7 halves. And 5 times 7 halves equals 35 halves. And then I'm going to subtract 7 halves. So 35 halves subtract 7 halves equals 28 halves. And 28 halves means 28 divided by 2, which means 14. So my expression would be equal to 14 when n equals 1/2. Okay, pause the video, go ahead and try it on your own, and then check your answer with mine. Right, we have 7xy, so that means 7 times x times y. So I have 7 times 2 and 5/10, because that's what x equals, times 9. Now again, I can multiply in any order. I don't have to do it the way that it's written out there. So I'm going to do 7 times 9 first and get 63, and then times that by 2.5. So I have 63 times 2.5, and I get 157 and 5 tenths. So the value of my expression is 157 and 5 tenths. All right, last problem. Remember that when we're dealing with it written as a fraction, we go ahead and do our order of operations on the top and then the bottom. So I'm going to do x squared first. So I'm going to do 4 squared and then plus, let's see, 2 squared. And then I'm going to divide that by 3. So 4 squared is 16 plus 2 squared is 4. So 16 plus 4 is 20. And then I'm going to divide that by 3. So I have 20 thirds. So 20 divided by 3. So 20 divided by 3 is going to be 6. That's 18 with 2 left over. So 6 and 2/3 is going to be my value of my expression. Okay, thank you and good luck on your assignment today.